Today, we sit down and discover what a part of a whole is. We're talking about fractions. Yeah, so we're talking about fractions today. I'm going to dive into equivalent fractions. If you don't know what an equivalent fraction is, that is a fraction that is equal to another fraction. So let's first just dive in really quick and talk about a few things that we might need to know for this. First off, if we're understanding this properly or really kind of grasping this, we know that a fraction is part of a whole. So for instance, if we take a shape and we split it in half, and we have one side, we know that this would be half. So it's part of a whole, the whole being the entire piece, right? So that would be one. And then this is half of that. So that's kind of what they mean by part of a whole. But when we talk about equivalent fractions, we want to find like something that is equal to 1/2. Okay, so let's dive right into that and look at what that means. So before we go back to these shapes, I want to take a look at a number line. And why is a number line important? Because with fractions, number lines might make it a little easier for you to visually see what a fraction looks like. And so I'm just going to say, when we're talking about this, say this is 0 and this is 1, and fractions are part of a whole, so in this case we'll have it between 1 and 0. And so for instance, if I take that same problem and say, well, what is half of 1, we would just go right in the middle, and that would be representative of this number line and that shape that we drew before. But we can also say what this is this is 0 over 2, and this is 2 over 2. So an equivalent fraction to 1 would be any number over itself. Now, you might already know that, but it's something that we can visualize, because first we have no halves, then we have 1/2, and then we have 2 halves, or 2 over 2, which in this case is 1. So when we put 2 halves together, that makes a whole. So goes that famous line. So let's get rid of that. And that's kind of what we're going for. So again, now what if we take this same number line and say, well, what about thirds? Okay, so we have 0, and then we have 1 again. What is that going to look like with thirds? Well, if we split it up, 1, 2, right? So we have 1/3 and 2/3. And again, equivalent to 1 would be 3/3. I'll put it up here so it's a little easier to see. But what about the 0? We don't have any, so we can say 0/3. There's nothing there. Okay, so now let's bring back our shape and let's think of equivalent fractions that are equal to thirds. And I'm going to move these down so they're a little easier to see. So here we have these two squares, and we're going to split them into thirds. And then we're going to talk about the math that goes into these problems and what all that means and how we deal with equivalent fractions, how we find equivalent fractions, all that stuff. So here we go. So we're going to break this into thirds. So if we think of this as a whole, right, I'm going to get rid of my number line. So if we think of this as a whole, right, one whole, and this as a whole, what is this split up into 3? Well, simply just split it up into 3. Now, again, when we draw pictures of fractions, our stuff doesn't have to be perfect. We just have to have an understanding of what we're drawing, because a picture is going to help us better understand what we're working on. Okay, so here we have 1/3. Okay, and we're just going to start. We're going to say we have 1/3. So I'm going to go ahead and label the 1/3. I'm going to color it in. Okay, and then we're going to have 1/3 here. All right, and if I want to make an equivalent fraction of this, I could split this up. But before I do that, I want to show you what 1/3 could be equal to. All right, so if I split this again, if I split this in half, notice I split what we already had. I'm going to do that again. So here's what we have, 1, 2, 3. We have half, and then, or I'm sorry, we have thirds, 1/3, 2/3, 3/3. Then I can split that in half, right? And now what do we have? Well, let's count it. We have 1, 2, 3, 4, 5, 6, and 2 of the 6 are filled in, right? So what we started with was a third, and now we got it equal to do that again. Get it equal to 2/6, right? Now, how did we get there? How do we get the third to a sixth? Well, if you start to think mathematically, you can see that it grew by how much? Well, the easiest one to look at is the 1. What times 1 is 2? Or how can we get that to 2? Well, we can multiply, right? We could add, but whatever we do to the top, we have to do to the bottom. And so in this case, we can multiply that 1/3 by 2. And again, we're multiplying by 2 over 2 because we split it in half. So everything doubled. Okay. And so the 1/3 can be multiplied by 2, and that would give us the 2/6. And so that's how we show the math. So 1/3 is equal to 2/6. 2/6 is an equivalent fraction of 1/3. Okay. So let's try that again. What happens if we split this up further and I make 2 more lines and I split the thirds into thirds? So I have 1, 2, 3, and then 1, 2, 3 going this way. So it's a 3 by 3. And so that would be, 3/9, right? So we now have 3/9. And remember, we started with 1/3. So what would make that one 3/9? And again, if we multiply it here, we can do the same thing here. And so we can start to see that we multiplied by 3. And so we multiplied 1/3 times 3 over 3. Did not change anything. And now we have an equivalent fraction of 1/3 that's also 3/9. So this works exponentially. We can keep going. We can do 4 over 4, 5 over 5, 6 over 6. And when we're looking for equivalent fractions, this is a really good way to kind of see it. So you can visually draw it, but then you can also show your work by showing the math and showing your process and how your brain is working through that. Cool?